following video we'll talk about the formula for a parallelogram and how we get it.
In my next shape here I have a parallelogram. So that means that this side and this side are parallel to each other, and these two slanted sides are parallel to each other as well. If this is my parallelogram and I cut a line down this edge and just broke this piece off, now if I move it around over here and stick it back on the other side, suddenly my parallelogram has now become a square. So I can either think of it that if I have a square and I push it this way and just tip it over, it becomes a pushed over square or a parallelogram. Or I can take my little piece, cut it out and put it back here, and I get my rectangle again. So therefore, if a parallelogram is actually exactly the same as a rectangle in terms of how much space it takes up, the formula for the area of it must just be the length times the width. Or we could think of it as, this is the length, we just need to know the height. So we can say length times height or length times width. Either is fine, and that is a parallelogram.
As we saw in the video, this is the summary. So the area of a parallelogram is just its base times its height, because it's just a pushed over rectangle.
If I want to calculate the area of a kite or a diamond, I need to figure out, well, what do I know and what does a kite look like? So to start off with, if I was to break the kite into 4 pieces, I would have a piece down here that makes up this little section. So if I cut that out and rotated it, I put it here. If I do the same thing with the other side, I take this piece and I cut it out and rotate it, and I do the same for these two. You can see that the shape that I end up with, I'll flip this the wrong way, the shape that I've ended up with is actually a rectangle. So this outline is just a rectangle. So if I knew the width and the length, or the height, whatever we call it, and I can see that my kite is actually made up of half of this, because I've just doubled all my pieces to create my rectangle. So I know that the area is equal to half of the rectangle for a kite. But I don't know a length or a height yet. However, if width is this side to this side, notice that within my kite, this edge to this edge actually are the same as this edge to this edge on the width. So when I wrote my half of rectangle, I could say, well, let's call this side y, for example. Doesn't matter what we call it, but we'll just call this point to this point y. Now when I want the height or the length from top to bottom, I can see that the inside of my kite does go from top to bottom. So if we call that y, let's call this x. Generally we write these the other way around just to be alphabetical, so I can call this half of x times y, and that's area. So the area of my kite is the x line, so the distance between opposite points, times by the distance between opposite points, which I'll call x and y, and then we just halve it. So that's all we need to do. I need to know the length from the top to bottom and length from side to side, times them together, divide it by 2 because the kite is half of that rectangle, and I've got my area.
Now we're going to look at the area for a kite. And as we saw in the video, the area of a kite is half of the product of the lengths of the diagonals, which sounds like a mouthful, but if you just draw a line from point to point and point to point, that length and that length, times it by each other and divide it by 2, because it's the equivalent of half of a square that that kite fits into. Now we're looking at trapezia or trapeziums. So this video will explain again the formula for it and how we get about it.
A trapezium is very similar to a parallelogram, except this side and this side are no longer parallel. They're both slanting inwards, so they're not the same. So if I had a trapezium and I wanted to know what the area is, well, generally on a trapezium we have two sides. So I know this side and this side. The only other thing I could need to know is how tall it is, which is the height. So if I took a second identical trapezium and I rotate it and put it next to itself, if this side was B, I've flipped it, so now this side must be B, and this side is now A. The thing to note here is the shape that I've now created is two parallel sides. Now the slants are the same. So this is now a really long parallelogram. So we know that the area of a parallelogram is just length times height, right? Because it's the same as a rectangle in terms of how much space it takes up. We know that a trapezium is half of a parallelogram because I've taken two of them to make my parallelogram. So I definitely want half of this. But I don't know what my length is. My height is here. That's fine. I'll normally be given that. But I don't know what these lengths are. So length here is actually these two ends combined. So it becomes A plus B. And just so I don't get confused about the order, I'll put it in brackets like that. And it's half of this. And that is my area. So the area of a trapezium on its own is just half of A plus B, these two sides, times by the height. And that is my formula for the area of a trapezium.
As we saw in the video, the area is the average length of the parallel sides times the distance between the parallel sides. So if we do A plus B, divide it by 2 and times it by its height, just like we saw in the video. Now I want you to do the following questions. So this is asking about the area of parallelograms. This question is talking about finding the area of kites. And this one is talking about finding the area of trapeziums. Now some practice questions. These are a little bit tougher. So here we want to know about the amount of material required to make a kite. So this is exactly the same as the area. How much material is the area? And here the total area of the stripes on the soldier's uniform. So think about what shape this is, what the area of each shape is, and then how many of them we have. And that'll give you the answers.